all the CSV and text files should be in the same directory as this file for it to run. So the first thing we have here is the neighbors class, and we're going to override the greater than and less than to allow for sorting in a priority queue. These are utility class to read the documents. And here is our k nearest neighbor. So the first thing we're going to do is going to talk about the weighted ratings method. So we're going to sum up all the Pearson's coefficient values for all the neighbors, and we're going to sum the ratings, the product of the ratings and the coefficients, and we're going to sum that out, and we're going to get the weighted ratings of the Then here is our Pearson's function. So here we're going to get the mean of the x record, mean of the y record, and the numerator is the sum of the product of x minus x mean and y minus y mean, and the denominator is going to be similar, but we're going to raise to the power of 2 for the x and the y differences with the mean, and we're going to square root that, and we're going to return that. So here is our get all neighbors function. So we're going to loop through all the training data, all the data, and we're going to get items that have been rated by the x and the y records, and if they have more than 2, we're going to calculate the Pearson's, and we're going to add a neighbor object to the priority queue, and remember it contains the Pearson for sorting, and we're going to put this in an array in a sorted order. So here's our predicted rating function. So here, the first thing we're going to do, we're going to get all the neighbors. It's called the function I just showed you. We'll get the users with the ratings and the neighbors with the ratings. If neighbors with ratings exist, we're going to get the top k. So we're going to slice the list, and we're going to compute the weighted rating of all those top k neighbors, and we're going to return. If not, then we just do a mean of the users that rated the item. Then for the k nearest neighbor, we're just going to get we're going to call the get all neighbors method, get all the neighbors, and we're going to slice it to the top k. Remember, it's sorted already, so I'm going to get the top k. So the get recommendation, we're going to get all the rated items by a user, and we're going to loop through all those unrated items. We're going to rate them and store those ratings, sort those ratings, and print out the books associated with those ratings. So for the MAE, we're going to loop through items 30 to 39, and we're going to get all the items that have been rated, and we're going to calculate the predicted ratings of those items that have been rated, compare it to the actual ratings. That's the absolute value of the difference of the actual ratings minus predicted ratings, and we're going to return that. So that's how we get our MA values. So for our UI, we have just this here for our UI, and pay attention to the instructions at the bottom. So I'll press 1 to show you the k most similar neighbors, and let's do for 35 and 10. So you can see the coefficient values. We can do for 39 and 10 as well. You can see those values. Then I can show you the predicted ratings for class for item 35, object 0 and k of 5, and you can see the predicted rating here. And we can do this for 39. Well, we can do this for 39 item 6 and the k of 10. So you can see this, that's a rating, and we can also show you the recommendations. So recommendation, the option is 3, and I'll enter 35 for the user number, 20 for the k, and 3 for the recommendations. And you can see the recommendation sorted. It calculated the ratings first, then it sorted it out and gave us those numbers. Then we can do that again for 36 and 10. Number of recommendations 3. You can see these recommendations here. Then I can show you the MAE value for k of 5, and you can see the MAE value here. So you just use the UI. Remember, the files should be in the same directory as the program file.